Hi everyone, in this video we're going to discuss clinical UPS2. For this question, which of the following pairs of the matrices can be multiplied? So we need to see on the orders. The first matrices can be multiplied with the second matrices where you were having the same number of column and the number of row from the second matrices. So the number of column from the first matrices and the number of row from the second matrices, that it should be same, then only it can produce a result of the matrices which is in the order of m times p. So this order is 3 times 1. So this is 2 times 2. So it doesn't have the same number that we want here. So look at here, this is 2 times 3. This is 1 row times 3. So this is not same. Then this is 2 times 3. This is also 2 times 3. So the column and the row is not same. And this one is 3 times 3. This is 3 times 1. Yes, it having the same column and the same row. So answer is this option. Then given matrix A, matrix B, and matrix C, find 2AB minus C. So first of all, we need to multiply A and B. So A, it have 1 row. B, it have 2 column. A is 1, 3, 2. B column is 2, 0, 1. 3, negative 1, 2. So we multiply it, we will get 2 plus 2, which is equals to 4. So this is also equals to 4. So 2 times 4, 4. Minus C is negative 1, 2. So 8 minus the matrices negative 1, 2, it will give you 8 plus 1, 9. 8 minus 2 is 6. So the option is A. Next, which properties of the transpose matrices is false? So option is this. So this is true. B transpose, BC transpose equals to C transpose B transpose. So the order should be inverse. So option is A. So of course this one is true, this one is true. And then for the next question, A is 2 by 2 matrices. So 2 by 2 matrices is having 2 rows, and determinant for this A is negative 2. When it times 5 to the matrices, so determinant of 5A, it will be expand 5 to the first row, so the determinant will be times 5. Expand 5 to the second row, also it will times 5 to the original determinant. So it will be 25 times negative 2. It gives us negative 50. So every time when we have one multiplier to the entire row, our determinant also will be times with the constant. So you expand 5, you have 2 rows, so that's why we need to times 2 times. So 5 for the first row, another 5 for the second row. So here we have this option. Given that this matrix A determines the value of determinant by using properties. So any properties that we have, or we can directly calculate A11 minus 11, A12 minus 12, A13 minus 13. So A11, we have 8543, so 53 over here, 84 over here, then vertically is 42. So to the AD minus BC, so 4, 2, at the back is 0, so it is equals to 0. So here we have option A. Given that the determinant of A is negative 5, find the value of x. So by expanding first row, A11 minus 11 minus A12 minus 12, A13 minus 13, this determinant equals to negative 5. So eliminate first row and first column, copy paste, in out, vertically we have x minus 3. 3x minus 3. Then we do AD minus BC and we expand until we can get the value of x. This is negative 4. So this is negative 5x plus 15. So this is negative 3x plus 9. Then we expand. So 7x, it will give you negative 5 minus 12. And then plus 4 plus 48. So it gives us 35. So x is equals to 5. So here we have our option. Next, which of the following statements are true? Minor to 2. Minor means cancel off to 2. You give you 3, negative 5, 1, negative 2. So AD minus BC, negative 6 minus negative 5. So it gives you negative 1. Yes, this is correct. And then C12 cofactor is equal to positive, negative. So 1, 2, position here is negative, minus 1, 2. So negative, minus 1, 2. When we cancel it, 0, 1, 1, negative 2. So 0 minus 1, it gives us positive 1. So this option 2 is wrong. So therefore, we have this option as an answer. So transpose is change the position from row to column. So this is correct. Given that P is not a non-singular matrices, means if P inverse is as is, such that we have this equation P cubed means PPP minus 2P squared, then minus 5 pi equals to 0. And I and O are identity matrices and new matrices respectively by P inverse. So by using properties, we will time in P inverse. So multiply at the front of the matrices. So P inverse, simplify, we get identity. Again, P inverse, we simplify, we get identity. So anything time with identity still maintain P inverse. Then we try to simplify. Identity time with P here is P squared. Then identity time with P here is 2P minus your 5P inverse. So lastly, we move this to the right hand side, it will be 2P minus P squared. So to get P inverse, it will be divided by negative 5 for this. So here we have our option, although this negative is out here, but when we expand it, it will be equivalent to P squared minus 2P. So determinant of P is 12, and its cofactor is this, P inverse. So it's given us cofactor, we can use the formula inverse. For finding P inverse, it will be determinant P times with its adjoint P. So adjoint P, it is equal to cofactor transpose. So we have cofactor already, we just need to transpose it. Transpose means changing the row to the column. So finally, determinant we put inside, adjoint we put inside here. So we plug in all the value and we try to find the nearest answer that we have. So we no need to expand, look like you already have in the option B. The following statements are true for the inverse of matrix A, except. So A is a non-singular matrix. So when you have inverse matrix, it will be non-singular. So only the square matrix can be inverse, like matrix of 2 by 2, 3 by 3. So all of them are square matrix. So matrix singular, A inverse not exist. Therefore, this is a false statement. To find A inverse, it is called 1 over determinant times with adjoint A. So adjoint A is equal to C transpose. This is true. So this option is not true. From the matrix form, AX equals to B, given that, by using Cramer rules, find the X. When you want to find the X, we need the determinant of AX over the determinant of A. Determinant of A is given, but determinant of AX is not finding yet. So to find determinant of AX means our matrix A will be replaced by our X here in first column. So plug in our answer. We have AX equals to B. Our answer is 6, 11, 0. So find this determinant, divide by determinant A. So X is this. So look like we no need to calculate the determinant. We just need to know its formula. Determinant of A is 9. So everything is divided by 9. Then we just only need to check this determinant of AX, which one is correct. So we have our option here, which is C, similar with option A here. So although we have two options that is same here, but you look it carefully where the difference is only with the sign. This is bracket and this is modulus. So to represent the determinant, it will be in modulus. So it will not in bracket. So option A is a trap to trap you. So our final option is C. Which of the following is not an operation in arithmetic row operation? So ERO, we have divided the row with entire row with a number. We have row plus row, we have row minus row, but we don't have a row that plus a value. So this is wrong. So in function, which of the following order pairs represent a function? Function, we need 1 to 1 or many to 1. So the answer only is 1. Okay, so we have 2 mapping to the 2 answer. This is 1, too many. This is not 1 too many. And then we look at here, -1, 0, 1, 2, and the answer 0, 1, 0, 2. So 1 to 0, 0 to 1, 1 to 0, 2 to 2. So this is many to 1. This is function. And we look at here, 1 to 1, 1 to -1, and then 2 to 1. So we have many to many. So this is not. Then -2 to 6, 0 to 4, 0 to 1. So this is 1 to many. This is not function. Find the domain for this set. So domain we calculate for this as LR. So set, inside the set here, we have to greater equals to 0. So when you divide by negative, we need to change sign. Therefore, it is x less than equal to. Here we have our option. Then what is the test to identify a function? So a function we are using vertical line test. Horizontal line test identify one-to-one function. So the question here is finding function, therefore vertical line test. So algebraic approach also for one-to-one. So that's all. Then which of the following function does not one-to-one function? Does not one-to-one function, normally it will have two sides like quadratic. So this is a quadratic. So this is not one-to-one. Cubic, this is S shape, it always one-to-one. Exponential, it is slide. Okay, this is slide in the shape. It is always one-to-one. Third is a wiper, whether going left, right, up, down. So it is always one-to-one. Therefore, quadratic is not one-to-one function. Given that fg is equals to x, function fx is this, and find gx. So we substitute gx into fx. So 4gx minus 3. So the place of x here, the bracket here, is represented by, substitute by our gx. Therefore, when we simplify, you unlock, the base e will be going opposite, then x become the power. Then move the 3, it become ex plus 3, and you move the 4, you'll get ex plus 3 all divided by 4. So here we have this option. So this function is a rational function where denominator cannot be 0. Find the value of k if substitute 2 over k into this function, it will give you 1. So it will be 3 over, substitute the 2 over k into the place x here, and the answer is equals to 1. We do cross multiplication. Here we have 4 over k minus 1. Then plus the 1 here become 4. And then cross multiply again. So k equals to 4 over 4. Therefore, k is equals to 1. Find the range of this trigonometry. So range for sine is a sinusoidal shape starting from 1, -1 to 1. And then we can see the coefficient here is 1. So therefore, its amplitude will be 1. Therefore, its range will be start from minimum -1, maximum 1. So minimum is included for this point. Therefore, we have close bracket here. So here we have this option. Given that this quadratic, and you can notice that this quadratic is in the condition only taking the right side. The following statements are false. So all of them is wrong. Just finding which one is true. It obeys the vertical line test. Vertical line test is for function. So quadratic is a function. Yes, it is true. So we are finding the true one. Quadratic, is it a one-to-one? Then I need to draw this graph. This is a quadratic. Minimum point x is 1, y is 3 here. So minimum point here is 1, 3, coordinate of 1, 3. And the graph only taking 1 to the right hand side. So when it taking that side means this quadratic graph here is not involved in the domain. So we only have this side. Yes, it is a one-to-one function. Its intercept as x-axis is 0, 2. X-intercept, we need to calculate y0. So when y0, x minus 1 square plus 3 equals to 0, move the 3, become negative. So move the square with square root -3 means this is complex number. When we have complex number, means this is no real root. When we have no real root means it do not have any intercept. This is wrong. And it does not have inverse. This is wrong. Because just now we already noticed that our function quadratic taking the right hand side here is one-to-one function. So of course this graph can be finding inverse function. So when it is one-to-one, automatic G inverse is exists. So option is 1, 2. Then given that here is a rational function, we need to find this composite. So f, f, f. F3 means f, f, x. So we need to substitute this 3 times. Firstly, we substitute the fx first, 2 over x. Then we substitute this 2 over x into the place of x here. Therefore, you have 2 over 2 over x. So 2 over 2 over x, we simplify, means 2 divided by 2 over x. We inverse it, become multiply x over 2. So simplify, it gives us fx. So what is your fx? Fx is 2 over x. So therefore we have this option. So that's all for this. Thank you for watching.